Welcome everybody. My name is Steve Hoberman. I am the manager of Technics Publications, and we publish the best books in the world on data. We have over 150 titles, and today we're celebrating the release of Bruno Freitag's Data Mesh Design. There are three reasons for these book celebrations. One of them is to make the world aware of our amazing collection of books on data. Second reason is to celebrate. There is so much that goes into writing a book. It's not just putting the words down on paper, whether it's 20,000 words or 50,000 words. There's so much involved in organizing thought and then working with editors and layouts and reading the book 100 times before we're satisfied and we go live and we produce the book. So these events are a great way to celebrate the success of the book and the accomplishments of the author. And the third reason for these celebrations is that there's always some key messages we like to get from the authors. And we're going to do this book release even a little bit different and more interactive, where you'll get to ask directly any questions you'd like to Bruno about his book, Data Mesh Design. It'll be more of a question response kind of format. Welcome, Bruno. I'm actually going to start by asking the first question, which is probably the most important question. Why this book? Why did you write this book?
Thank you, Steve. Thanks for the opportunity and welcome, everybody. I'm really thrilled to have you all here. And honestly, I'm nervous as hell because it's my very first book release. So I hope I can give straight answers. And I was asked a few times, why did I create the book? And I wasn't clear myself what it actually was. Of course, we created the modular data lakehouse. We implemented it, we scaled it, and then we realized that the thing actually became a data mesh. So it complemented the design and the technology to Zamak's book. So what to do actually physically on the ground to make the thing fly. And then, of course, once we realized it, we wanted to share it with an audience. And finally, my wife gave me the lightest kick and said, why don't you write the book? So that's the reason. It's really making known what we did, because it complements what Zamak wrote in her great book. Not the people side, the organization, but the hard stuff. How do you design a data mesh? What data mods do you use such that the thing really becomes modular?
It's interesting. Yeah, they were, when I read the book, there were some really neat things. I don't want to take too much away because we want you to get the book, but your ideas on things like having primary keys that are reused across the environment. I mean, could you share more about your original thinking on what triggered your original thinking on the book?
Well, the original thinking was quite simple, and the original motivation, to be openly honest, was different than what it turned out in the book. I'm old enough and I've done dozens of mistakes, lots of mistakes. And I've seen quite a few initiatives falter, fail, stall, because they grow in complexity just beyond being manageable. So originally, we wanted to design something that is truly modular and that doesn't break down by its own complexity. So simplifications wherever possible was a key driver. Because I sometimes compare it to Lego. You only become truly modular if you can add new pieces, irrespective of how many pieces you already have. Otherwise, in complex real-life environments, the thing will fail. Then, of course, I was working in complex environments. And I worked a lot with integrations across many, many different systems with different philosophy. And I'm old enough to learn that you're never going to make assumptions about data because it's indefinitely been proven wrong. So whatever assumptions you make about data in real life, you're mistaken. So no assumptions. So the challenge was then, given such a complex enterprise with different systems, different philosophies, contradicting identifiers, synonyms for the same thing in different places, how to integrate that, how to integrate such heterogeneous systems, which led then to some specific designs that are outlined in the book, like the inherent use of synonyms, infinite hierarchies that can deal with contradicting hierarchies as you find in every company, and some other tricks. Also, originally, the thing was done for data science and machine learning to train the models, needed integrated data, and only later we realized what value it was, not just for these guys, but also for business users, because it had a wealth of information. But ultimately, it was then this passion for simplification, because the users don't care about the complexity of a particular application or system in your enterprise. They simply want the business facts. And we had heated debates about data vault or not. To give a hint, you can do it simpler without one. So we were looking for simplifications, a simple approach, a proven approach, and actually it works.
Yeah, I love.
Hope I answered your question roughly, Steve.
Yeah. There were such good analogies in the book too. You mentioned the Lego, and I especially like the train, those train tracks, and the train analogy you have for the data mesh as well. And if you could talk more too about like what are some of the key ingredients in the design outline for data mesh design?
When Steve
Also,
talks
please.
to train analogy, can you share the slide, Omar? I guess it's 17.
Oh yeah, let's definitely do that too. And also remember, if you're attending the event, feel free to put in the chat window questions you have for Bruno as well. So thank you, Bruno. I'll turn it back to you.
I use the train analogy actually for two reasons. Three probably, we'll find out. One is with a series of rather simple pieces, you can create a myriad of different railway tracks. I mean, you have forks, you have curves, you have straights and bridges and some other things. You can create a myriad of different layouts. And for me, such a layout is a business question. So the whole point of the data mesh design is to address business questions as close to the way that the business user formulates it. And if you listen to a user who asks you a question, he's telling you a journey. He's telling you from SAP, I get the customer, and then from the customer go into Salesforce and look for his parent company, and from there on I look at the revenue, and he's telling you a data journey. He's going from one piece of information to the next piece of information. And that's, for me, similarly to a railway track journey. You go from one piece to another, and you connect those pieces. In star models, you might have heard the term common dimensions. We use the same concept on steroids. There are standard ways how we define the keys between individual objects. They're extended natural business keys, and they fit together. So like railway tracks that always have the same connections, so those hooks and whatever the word is that you bind together, it's with data. And once you can define those and have agreement how those look like, you can, with a relatively small set of elementary pieces we call them mini-marts in a book, address a myriad of different business questions in a very fast, in a playful, in an agile way. And the whole point is to be able to create address different business questions quickly, iteratively, fast, because that's the point of it. And mini-marts are nothing else but the railway tracks that then pretty much everybody can stick together for his own business needs, business questions. And the complexities of the various source systems are hidden underneath. you don't need to worry about it anymore.
That makes a lot of sense. Yeah, thank you. Thank you, Bruno. I'm going to open it up for questions from the audience. And we have one that was submitted. Did you have any later insights after you wrote the book? That's an interesting one, because often what happens is the book is out there and there's no undo button once it's out there already. And you kind of like, well, what did I learn along the way? What could I have done better? So yeah, if you could share some of those insights.
People again. And people for three areas. A, we do a lot of simplifications. And I don't mean simplification in a bad sense, I mean simplification in a very positive sense. Reducing the data to the very basic question, what does the data tell me? Sounds simple, isn't it? Yet, for experienced data engineers, it's really a leap of faith. They are trained working with cardinalities and precision, while we still are precise, precision in a different way. And it was very challenging for them to abstract from the technical implementation, how a particular source system implements things, into the generic meaning for business. Because if you ask a business user, what does that data mean to you? He's not talking to in LAKPSKNNR or whatever table numbers. He's giving you a plain English or Spanish or German, for that matter, sentence. And that's the way data structure. And getting business engineers to really start the design from the basic English sentence, what does the data mean, was way more of a challenge than I had. The next was data ownership. Of course, data in Minimart is correct if it reflects what in a source system, so information is lost. It's a trivial statement. Nevertheless, you need business owners that give that trust, that credibility, that confirm that it matches, and also that handle access, who is allowed to see what data, those things. I underestimated that. And the last thing that ultimately led to the data mesh design, people want autonomy. People do not want to succumb to a global organization that has their own priorities, their backlogs. They want to get at their data here and now. And that ultimately drove data mesh. So once we had the original thing, various regions wanted their own thing. And we realized by the inherent design, it's possible. So we can give people the autonomy. But it also means that those central headquarter guys have to give up a bit of control. They have to trust the people outside that they do their best. So offering that training package between architecture, how you do it, platform, how it fits together technically, but also training and autonomy was way more of a challenge, because depending on the enterprise, it collides with how some, not all, but at least some IT departments see themselves as the head of the world. They're not.
Interesting. Thank you. Thank you, Bruno. A question just came in as well. Let's see. Hey, greetings from Kentucky. There's often a disconnect between business owners' expectations and what a system can give them at its current level of development. Do you have any suggestions about how to communicate complexity to stakeholders?
Thank you. It's an interesting one from Andres. Hi, Andres. Glad to see you here. There are a few pieces in your sentence. It's business owner's expectation, system, and current level of development. Current level of development is a question of backlog, priorities. There, I can't make any judgment. It's ultimately the game who cries loudest, gets most resources. The other part, business owner's expectations, what the system can give them. That's probably close to the first point I did around people. If you design a data mesh and the minimarts from a technical point of view, basically what tables are in there, you're lost. You create a convoluted mess that nobody understands. Start from the other end. Start from the business user's expectations. When the business user can tell you, look, this data, this screen, the way he sees the data means this, and this to me. So one of that screen tells me that. Then you start your design with the business user's expectations and not with the system's constraint. And I think that's the way. So really, that's also the key sentence I use most often. What does one record tell me? One row, one entry, one anything. And it's surprising, it frequently took 3, sometimes more iterations till people, data engineers at least, were able to express the meaning of the data in its purest, simplest form without using a system. Simply, what does it tell you about the world? So in that way, how to communicate complexity to shareholders? You don't. You start with the business expectation, translate those into the minimarts, and fight for the resources that it fits into your development pipeline and gets priority 1 and not priority 5.
Thank you.
I hope it helps you, Andres.
Thanks, Bruno. And thanks for that question. Other questions? Let's see, we have one here. How did the solution, and this kind of builds to a previous question too, how did the solution design content kind of evolve? So I guess it ties back to the initial project you were working on that led to the book, but if you can explain that evolution, that would be interesting.
Yes, you're correct, it ties back to the beginning one. As I said, it started with my experience having integrated a lot of different systems. And I kind of sharpened my thinking for canonical formats and stuff like this, really trying to see the meaning of the data, how business users expresses it. And a little side remark, one key point was when a business user who had no idea of data structures was looking at the screen, a diagram, and said, that's not correct. Wow, we've won. Because if you can express data to a business user in a way that he can find mistakes, then you won. So it's the background of having integrated a lot and not wanting to repeat some of the past mistakes. Originally for data science. And then we realized that actually the fact that it is modular, that one object does not depend on another one, makes it suitable for a data mesh design. Because you could extend existing objects or create additional objects without needing to bother what's already existing. And that's a key requirement for a data mesh to really land. And that's how it evolved. And I guess it was India first, or APAC, I don't know anymore, who wanted their own thing. And then soon North America came and R&D came, who wanted their own area.
Interesting. Other questions here. Thank you. Keep the questions coming. A question here. How do you envision synthetic data infusion as feature engineering on products evolves over time?
You honestly, to push me a bit to the limits with synthetic data infusion as feature engineering. I can talk of feature engineering. Synthetic data infusion, I'm not a professional on data science, so I rather shut up on that one. Because the data science and machine learning guys will know much better what that means. But on feature engineering, there's an interesting thing that turned out. When we're talking with our data science, machine learning guys, they were used to doing the feature engineering in elaborate pipelines. That, the Panda data frames and all that stuff. So they're pulling huge amounts of data from the server and then doing the features. And at some point of time, we realized that we can put all this heavy lifting down to the server and only get the feature, which had two advantages. One is what I just said. It's pushing the heavy lifting as deep down in a stack as you possibly can, which reduces costs, naturally. And second, you can use the same logic whether you do the training of machine learning models. That means your aim is getting a few thick thousands of rows back to train your model, or whether it is to execute your models, where you need the same features, but for a particular instance or execution, or whatever the term is, for a model, in operational terms. In that sense, it was helpful. Whether you call them the features or have a feature marked, a product, that depends on the maturity of the organization. Whether the organization is mature enough that the results of feature engineering become data products in itself, that get published, have a life cycle, have an owner and everything else, and get reused, that's beyond the scope of the book.
Volume 2, that could be the next book. Yeah. Great.
And I need Yannick to help.
Another question here. How does data strategy influence the approach you describe in your book?
I assume with the data strategy, you mean kind of the data strategy that's inherently underneath the book, I assume. Of course, there's never a free lunch. And I've seen more than one, put it mildly, of those virtual environments, don't use products here, fail. Because they wanted to integrate data at volume, at scale across different platforms. So I think this platform is pretty much irrelevant. It's not a distinguishing factor nowadays anymore. But you need, if you want to play things together, you need to agree on one. You cannot easily play together with Lego and Playmobil. Playmobil is just topple on the Lego X. So insofar, data strategy has to give some technology limits that you can, in reality, not just on a sales slides, integrate the data, even if you have billions of records. And of course, then all the other data strategy aspect of what's the role of a node? Do we even have a business owner? Who owns the data? How decentral can you organize it? Is then the other area. But I think those things are very well expressed also in Sabak's book. I do not focus in my book too much on data strategy. I focus on how do you do it on the ground, and then probably derive the data strategy backwards.
Thank you, Bruno. Oh, we have a question here too. I'll read it. Traditional data warehouse architectures typically rely on layered and tightly controlled data processing methods, while modern data mashup approaches offer more flexibility and rapid data integration. When integrating these two methodologies, how can we maintain the data integrity and reliability provided by traditional data warehouses while leveraging the agility and speed advantages of a data mashup? Interesting. In the integration process, especially in the context of big data and real-time data processing, what are the main challenges encountered, and what advanced techniques and methods are recommended to overcome these challenges? Additionally, what are the impacts of the integration on business intelligence and data analytics processes, and what kind of transformation is required in these areas? It's actually, I can tell, Yusuf, you probably have worked in the trenches in this area too. And I know, I'm sure in Bruno's book, when he talks about things like having the keys that cross areas as a way to do integration, and I don't want to steal his thunder, I'll turn it over to you, Bruno.
Thank you. There are lots of questions in there. I tried to scribble down some of the buzzwords, but can't read my own scribbling. So I have the question up and go down by one. First one, if you look at the words, are layered tightly controlled data processing methods. I mean, nothing but replaces or a tightly trusted method for data. I mean, whether your target is a mesh, a mashup, a fabric, or anything, you must be able to trust the data that's in there. no matter its granularity. So whether each mesh node, this decentral organization, controls its own processes, it's accountable for, whether they hand it over to an operational organization is up for grabs. But nothing replaces the means to tightly control, monitor processes that get your data in a data lakehouse. In that sense, we're the same. Then data mesh, more flexibility. Maybe. I use the example of the railway tracks. The processes by which the individual tracks are created, populated, the pieces, is very tightly controlled, no question. Yet, any data scientists, any data visualization engineers, any data-savvy business users can tuck them together in a way they want. So the rapid integration isn't in a process left of the minimarts. It's the inherent design how the minimarts are constructed. Because once you have the minimarts in front of you, the source system is nothing else but one of those provenance columns, audit columns that tells you where the data comes from. Otherwise, you don't see a difference. That means you plug those things together irrespective of source systems. The difference is ironed out in a layer before. So we get tightly controlled process, we get trusted railway track pieces that can stand the test, yet integrating them is very flexible by the inherent way how they're designed with the extended natural business keys and some other conventions. Then let's go forward. Yes, traditional data reliability. So reliability, the same stuff. Whether we have a traditional data warehouse or not. If you don't control your data ingestion and processing, you're lost. Advantage of mashups I just talked about. Big data real time. The biggest, if I'm not mistaken, entry we had about 12 billion rows. And the largest table we had in our environment had about 700 columns and more than 1 billion rows, so decent size. Whether you call that big data, big data is a platform quality question and not a design question, unless you talk of unstructured data. The next thing is then real-time data. Again, real-time data is a technology and process question. Whether you have a technology and a process where you can update your data lakehouse in 30 seconds intervals, in 2-second intervals, or in 30 minutes intervals, is a technology, not necessarily a design question. From a design in a book, it leaves it open. You can choose any, and we go down to relatively small times. Some others are large. So that's not the big thing. Roman, what's the next? I said some advanced techniques, methods to overcome those challenges. I said I don't see a context in it. Like I don't believe in slowly changing dimensions. Either it's changing or it's not, because what's slow and fast changing. I either need to take care of changes or not. So integration, business intelligence, data analytic process. The last part is also an interesting one, because it's the precision of the question. Ultimately, the minimarts are free of business interpretation. They just capture the data, what it tells you from a business point of view. It doesn't tell you whether it's good or bad. It's just the pure facts. Interpretation is then in BI. So as soon as you make a data analytics process is a feature for engineering, a specific report, you add interpretation. So we have the 3 pieces. We have the pieces of a trusted process to feed up the minimarts. We have the ability to connect those objects in an agile way, in whatever way you need for a specific question. And that's the last part, which is what is the precise question? And nothing solves that one. You have to ask the right question. and whether there is a rule that all the sales up to the 5th working day are considered previous months and thereafter the current months, then that's a business rule that you need to coin somewhere. So these three things I see independently of each other. I hope I addressed it, Yusuf, in that sense.
Thank you. Thanks, Bruno. Thanks for the question, Yusuf. We have time for one more question. So Manian's question here, any way to have the data mesh design can achieve end-to-end data integration configuration archived along with data as a single unit, from data governance practices to archive and retrieval of data to minimize business compliance risk? And keeping data for a long time comes with a cost. Interesting.
Yeah. I hope I get the questions correctly. Start from the beginning. The book explains a pretty elegant way also of historization of data changes, and actually even a way of dealing with virtual snapshots, because many business requirements want the data as of end of months, let's say inventory end of months, but what do you do with daily inventory? So the archiving is, some of it is in a design. The next question is a data volume question. I mean, you can't beat physics. If you have so much data that blows up your physical storage, there is no way to change that. No design or nothing can change it. Yet the book relies on compression methods of modern columnar stores. And that's a pretty nifty feature. So why should I use my own energy, complexity, and brain to kind of minimize redundancies if a smart columnar store can do it underneath? And I can really focus the data on the simplicity of the data, like you see it in a simple Excel sheet, in a simple way that user understands the data. So archive to retrieval of data, I don't know whether I understood the question completely, but the components in there are the changes, the compression, the virtual snapshot table, and as a side remark, the book also tells you about lineage, that you have the complete lineage of which data flowed through which steps into which endpoint. Whether that addresses your point, business compliance risk or not, probably needs a deeper analysis.
Great. Thank you. Thank you for the question, Manny. And thank you, Bruno. We've come to the end of our time together. So thank you everyone for attending. Thank you, Bruno. And we all look forward to reading your book, Data Mesh Design.
Here it is.
Here's the next release.
As said, it's very down to earth. Don't expect an academic book full of formulas. Expect something that goes down to actual code that worked in actual environment, so things that work on the ground.